Okay, so let's do a more specific example for our labor market now, where we'll actually put in some values for all these parameters that we've been talking about, and then calculate the equilibrium and see what happens. Okay, so we're going to keep this very simple to start with, and say, well, let's let the set of types, capital theta, equal an interval that goes from 5 to 10, okay, in whatever units they're measured in. Okay, so this is, each individual is able to produce either 5 units or anywhere between 5 and 10 units when they're employed. Okay, and we're going to make an assumption about this reservation wage function. So let's let the reservation wage of somebody who is type theta equal theta for all theta. Okay, so this is just saying, well, whatever money I make for the firm, I expect to get paid that. Okay, that seems rather demanding, but remember, in a competitive market, you would expect firms to make zero profit in equilibrium. So getting paid what you produced is not unreasonable. Indeed, under perfect information, if we remember, so if we just did this example with perfect information, we would get that the equilibrium wage would depend on theta, and each type theta would be paid precisely theta, which is precisely what they would accept. So we would have full employment. Everybody would be employed, okay, at exactly the wage they want, and the firms would make zero profits. So all of the benefits goes to the employees. Okay, so that would be the perfect information case, full employment. So in a competitive market with perfect information, we expect everybody in this case to be employed. Okay, the only reason they wouldn't be employed is if they had a better offer elsewhere. So if this function was different, if they had a different reservation wage. Okay, now let's talk about asymmetric information. Okay, so asymmetric information. So what are we assuming in asymmetric information? Well, that every single type of worker knows their own theta, but there is no way for anybody to verify this theta. So the firms don't know the theta. So there is a market wage W, and it's just fixed. It doesn't depend on theta in any way, because it can't, because that information is simply not available. Okay, so how would everybody respond to this? So let's look at three cases. Case one. So let's suppose the market wage is W. Okay, well, if W is less than 5, okay, so the lowest type has productivity 5. His reservation wage is equal to 5. So he doesn't want to come to work. So everybody goes home. So all the thetas reject the offer of employment, and everybody goes home. So this expected revenue, expected productivity, the expected value of the theta that are employed, that's the condition for which they accept employment, is not defined. Okay, we're trying to take the expected value of an empty set, which we can't do. You could take it as 0 and amend the definition of equilibrium slightly, but we'll just say it's not defined. Okay, so that's case one. What about the more interesting case? If 5 is less than or equal to this market wage, and it's less than 10. Okay, so in this case, we're going to have some people accepting employment and some people turning it down. Okay, so let's be more specific. Say, well, then who will accept employment? Types in the interval, so types theta that belong to the interval from 5 up to W. Okay, So the individual whose theta is equal to this W will accept, because R of theta equals theta. As soon as theta goes higher than W, that type of worker won't come to work in this case. Okay, so these accept. These are the types who accept employment. And so the firm's expected revenue, expected productivity, conditional on this, conditioning on the fact that those who work accepted the market wage, will be, now remember how we calculate the expected value of a uniform random variable. We've got an interval here, 5 to W. Types are uniformly distributed on that interval. And so the expected value will be halfway between 5 and W. So a half 5 plus W. Okay, so that should be a round bracket. So 1/2 of 5 plus W is the expected value when the wage lies between 5 and 10. Okay, so what about if the wage goes even higher? Okay, so really we're just responding to a market wage here. So it could be any value. We just see the value and respond. So whatever the market picks, we don't know yet. So if it picks a very high wage, so if it picks a wage that's greater than or equal to 10, well, what happens then? Even the most productive person who has productivity equal to 10, his reservation wage is equal to 10, so he will accept employment. So all types accept, okay? And then the expected revenue or the expected productivity, conditional on those who come to work, will be, well, it's this entire interval 5 to 10. Types are uniformly distributed on this interval. So I just look in the middle, okay? So just 7.5, okay? Now notice that as W goes higher and higher and higher, this expected revenue is fixed. It's just staying at 7.5 because as soon as the wage goes above 10, it just, productivity is no longer going up because there's no more productive people to join in employment here, okay? So let's sketch a diagram of this. It's always a good idea to sketch a diagram before calculating the equilibrium here, okay? So let's just write, and I've prepared a diagram here with wage on the horizontal axis, and we're going to have expected revenue on the vertical, and I've drawn in the 45-degree line. I'll mention why in a moment. So if we remember what we just worked out, our expected productivity or expected revenue conditional on the information that only those with reservation wages not exceeding the market wage come to work is equal to, and it had 3 pieces. So it was, well, it's not defined. Just put not defined if W is less than 5. Okay, it is 5 plus W over 2, halfway between 5 and W when 5 is less than or equal to W less than 10. Okay, and it was equal to 7.5 when W is greater than or equal to 10. Okay, so this was the expected productivity equal to expected revenue function as a function of this W. So let's do a plot here. Well, below 5 it's not defined, so let's take that 0.5 there. And then when the wage is equal to 5, this is halfway between 5 and itself, which of course is just 5. So I've got 1 point there. It then increases, it's linear, it has slope 1/2. And then when the wage is 10, the expected value is 7.5. So on the 45-degree line would be 10. I'm going to go halfway between the two. So say about there. So let's just label that point. That's 7.5. Okay. And then after this, so let me draw this piece. It's a increasing with slope 1/2. It's a straight line, okay? And then after this point, as the wage goes higher and higher, it's just flat, this at 7.5, okay? So let's just draw a flat straight line ever after, okay? So it has this period of not being defined, then it's increasing, and then it's flat. Now, the reason I would always suggest drawing all of the pieces of this in a diagram is that sometimes the equilibrium will happen on this increasing part, sometimes it will happen on this flat part, okay? So it's important to kind of get the diagram straight, and then you'll have a good idea of where to look for the equilibrium, okay? So what was the equilibrium condition? Well, the equilibrium condition, if we combined our first and second conditions, we got a necessary equation that said the equilibrium wage W star has to equal the expected, this is the cost of employment, has to equal the revenue or expected revenue at W star, okay? So here W star appears on both sides of the equation. It's like a fixed point condition. And what this graphically is saying is if I plug W into this function, when does the same number pop out? Okay. Now remember, when I plugged 5 into this function, 5 popped out. Okay. So another way of interpreting this condition graphically is saying, where does this diagram cross the 45-degree line? Okay. And in this case, it crosses the 45-degree line in only one place, right there. Okay. So now we can describe the competitive equilibrium of this market under asymmetric information. It's two things. So it's an equilibrium wage W star is equal to 5, and a set of types employed, capital theta star. Well, who's going to accept this equilibrium wage? Just one type, the type whose productivity is equal to 5. Okay, so that was the kind of mathematical exercise of solving this problem. Now it's time to stand back and marvel at the terrible implications of this, okay? So remember that for perfect information, everybody got paid what they wanted and there was full employment. As soon as we have asymmetric information in a competitive market that is otherwise as perfectly functioning as you can imagine, everyone is perfectly rational, there is no friction, there's no other problems, just that one problem that we can't identify types. The wage crashes to its absolute lowest value, and the only type of person who gets employed is the very worst person, okay? The least productive person. In fact, I know that it looks like there's one person being employed here, but remember, a single point has 0 length. So there is, in a sense, 100% unemployment here. Okay, the entire market has, this is called market unraveling, which sounds like a dynamic process, but it really isn't in this case. It's just the market just won't exist anymore. Okay, this market, there is 100% unemployment. Anyone who is even slightly better than the very least productive type here cannot be employed. Only the very worst person, what we call the man of brass or the lemon, is the only type of person who can get employed here. Everybody else is unemployed. Okay, so there's two things going on. First of all is how the terrible level of unemployment in this market. This market is just completely crashed. This market will no longer exist. Okay, when if there was perfect information, there would have been full employment here. So the first thing is that there's as high unemployment as you can imagine. It's an extreme example. The second thing is the thing called adverse selection, which means, well, there is really one type who could be employed here, but it's only the very, very worst, okay? You would intuitively think if we're going to just use one person, let's use the very best. But no, in a competitive equilibrium, as soon as we have asymmetric information in this particular parametric example, the only person who can be employed in equilibrium is the very worst type. This market has completely unraveled. Okay, so let's do another example, which is very similar, but we'll just adapt one of the assumptions we made. Really, this is for two purposes. One, to get to grips with handling this type of exercise and this type of analysis. And the second, to show that, to kind of check the robustness of our conclusions. I mean, was the severe unemployment and adverse selection, did that just come from the specific example that we chose before? And obviously, that was a very extreme example, but we're going to see similar results again. So in this case, we're going to let the set of types be uniformly distributed on that interval 5 to 10, okay, as before. And we're going to now assume that this reservation wage is a little more forgiving. So the reservation wage for somebody whose productivity type is theta is equal to 0.8 times theta, okay? You could practice doing this with just some parameter alpha times theta. That's what you'll find in the lecture notes, okay? So how does this change the results? In our previous example we just had, r of theta is equal to 1 times theta. Well, here the employees only need 80% of their full money that they create for the firm. They will happily accept 80% as their reservation wage. If they are offered more than that, great. But if they're offered less than that, they'll walk away. Okay, so let's run the exercise again and see what happens. So there's various cases. So if the wage is low enough, then nobody's going to accept the wage. So when does that happen? Well, if the wage is less than, the lowest type is 5, and 0.8 times 5 is 4. So if the wage is less than 0.8 times 5, which is 4, okay, then even the lowest, the least productive type here will not accept that wage. And so the expected revenue function, the expected value of productivity, conditional on the acceptance condition, is not defined. Okay. Second case, the more interesting case. So now if the wage, so what do we want? We want to say, well, I want some people to accept, but not all people to accept. Okay, so this is kind of the interesting case. So let's say if 4 is less than or equal to the wage, which is less than, and then the highest person who has productivity 10, they need at least 8. So if we say that this is less than the 0.8 times 10 case, so at least the highest person won't accept this wage, okay? So some will accept and some won't. Well, what happens then, okay? Well, one way of thinking is, well, who's the best type of, who's the most productive employee that comes to work, okay? So the highest theta that accepts, we know the lowest theta is 5. What's the highest theta that accepts? Well, it occurs where, let's give this a name, let's call it theta tilde. Is the theta tilde such that what happens? It's when they're precisely indifferent. Okay, so the wage is exactly equal to 0.8 times theta tilde. Okay, so if theta tilde is any higher than this, the wage won't be high enough. Okay, so this is the highest, the most productive type that will come to work. Okay, so if I rearrange this, I get that theta tilde is equal to the wage divided by 0.8. So how would I write that? 10W over 8, okay? So this is the most productive type that comes to work. So now the types, I suppose I could write the capital theta as a function of W. The types that come to work will be the interval, all the types in the interval from 5 up to 10W over 8. Okay? Okay, so now I know who's coming to work. I can calculate the expected revenue, expected productivity, conditional on the assumption that these guys come to work. And these are uniformly distributed. I've updated my interval. So with probability 1, this is the interval. So I'm going to look in the middle of it. Okay, so I'm going to say halfway between 5 and 10 over 8 times W. Okay, so there's the expected revenue when the wage is in that interesting interval where some types accept the wage and come to work and sometimes don't. Some types don't. Okay, so what about the third case? Well, if W is high enough, so if W is greater than 8, okay, it doesn't need to be greater than 10. If it's greater than 8, then all types accept, even the very highest. And so what's the expected revenue then? Well, if all types accept, I know that productivity is uniform on 5 to 10. And so the expected revenue conditional on this high wage level is 7.5. Okay. So it's a very similar construction. We just needed to do this extra bit to figure out what this interval was. Okay. In general, if you had a function r, so if this value here is essentially r to the minus 1 of w. Okay, that's how we got this. So I inverted the reservation wage function to find the highest, the theta tilde. So if you had a different reservation wage function, that's how you would handle it. Okay, so let's produce a diagram of this. Before we look at the equilibrium, let's produce a diagram. So I've prepared a diagram here. I've marked in wage on the horizontal axis, and I've marked in this 45-degree line here. We had that the expected revenue, conditional on that acceptance condition, was so not defined if W is less than 4. It was halfway between 5 and 10 over 8 W for when 4 is less than or equal to W less than 5, less than 8, apologies. Yep. And equal to 7.5 when W is greater than 8. Okay. So we had the 5 and 10 from the previous example. We went up to here. Now in this case, let's sketch a diagram here. It's not defined when the wage is below 4, and when the wage is equal to 4, this is precisely only the lowest person accepts. So that would be that point there, which is 5. Okay. And when everybody is employed, or sorry, when the wage is 8, everybody is employed, in which case we get 7.5. So here's, I go all the way up, there's 8 and come down a bit. And let's call that point there 7.5. I'm not drawing this perfectly to scale, but giving you the idea. So this was linear with slope. The slope is 10 over 16, right? W is being multiplied by 10 over 8 times a half. So 10 over 16, 5 over 8. Okay, so it's a little steeper than it was before. And then once we get to the wage is equal to 8, everybody accepts the wage. Productivity is 7.5. And after that, it can't go any higher. So it just has to flatten out and stay equal to 7.5 ever after. Okay. So there's a diagram of the, so this diagram here is our expected revenue conditional on the fact that the reservation wage for the types who come to work does not exceed the wage. Okay. So where's the equilibrium? Well, remember the equilibrium condition said if I plug a W star into this function, the same number should pop out. So it's kind of a fixed point condition. Okay, so if I plug in a W and the same pops out, graphically, that means where does this function cross the 45-degree line? Okay, now I can see, because I've drawn it very carefully, I know I can just focus on this part here. Okay, sometimes it might be on this part, but in this case, it's going to be on the increasing part. So if I want to solve this, then I'm just solving an equation. W star is equal to 1/2 5 plus 10 over 8 W star. Okay. I won't go through that in the video, but I will just jump to the solution and say that W star in this case is equal to, where is it? 6.67, 6 2/3. Okay. Which, do a sanity check your diagram, just make sure it looks about right and go, okay, that's good. So the equilibrium wage is that, and then the equilibrium set of types. Remember, an equilibrium is two things. It's a wage and a set of types who are employed. So it's going to be all of the people of type 5 up to where? Well, not up to 6.67, okay, because people of type, for instance, 7, this is probably enough for them. So it's going to be all of the people up to 10 over 8 times by 6.67, okay? Which I got to be 5 up to 8.33, okay? 2 decimal places. Okay, so again, now that we've found the results, let's just make some comments on these results. Okay, so there is unemployment. Okay, so what percentage are unemployed? Let's see. So percentage unemployed, we could calculate as 100 times by, and then do this fraction and say, well, this length of the total interval is 10 minus 5. Apologies, that'll go on the bottom. And the length of this interval is 3.33. Okay, so that's the portion of that line that are, apologies, that will be the unemployed ones. We want the 10 minus 8.33, the people who are not employed. Okay, so if we do this exercise, then you get, this is 0.33, so you get an unemployment of 33%. Okay, so 2 things to point out. One is that unemployment's incredibly high here, and we know that if there was perfect information in this market, there would be full employment. So all of this unemployment is purely as a result of asymmetric information. Okay, so that's one thing. And then the second comment to make is, again, it's about the type of unemployment here. This is not just any old people being unemployed. It's the very best. Okay, it's the most productive people in this economy that are not being employed. Okay, so the people who are employed are, in a sense, the lemons are being chosen by the market mechanism, the men of brass. But the most productive types are simply being unemployed by them not being selected in this market, which is why we call it adverse selection. In this lecture, we've studied Akerlof's famous model of the market for lemons. We've worked on one specific example and application of these ideas to the labour market, although there are many more examples one could think of. Akerlof's famous example was to do with second-hand cars. So why are second-hand cars traded at such a lower price than brand new cars? And adverse selection is a large component in explaining this fact. There are many other applications, such as why credit markets struggle in developing countries and so on. And I've prepared in the lecture notes some references to empirical papers so you can see the types of evidence supporting Akerlof's ideas. In the next lecture, we're going to be looking at an idea called screening in a model due to Rothschild and Stiglitz. Joseph Stiglitz is another Nobel Prize winning economist for his work on information in economics. The key idea in the screening model is that by designing contracts, which you can think of as prices with several dimensions. So typically in microeconomics, we think I sell you a good for a certain price. Well, a contract has several dimensions. I sell you a good for a certain price, but in a different state of the world, the price may be different. So we can have price depending on the state of the world, or wage depending on the state of the world, and so on. We'll look at an example of an insurance market and how you can cleverly design these contracts in a way to separate the different types of decision makers in the economy, even when there's asymmetric information. It's almost like an economic lie detector. So, exciting stuff. I look forward to seeing you next time. In the meantime, take care.